Identify the type of solid and volume for each figure below, then find the volume of each figure. For cones, leave your answer in terms of pi. Speaking of cones, if we take a look at this first picture, it does happen to be a cone. We have a circular base. The formula for the volume of a cone is 1/3 times pi r squared times h. And before we get too involved in this one, we have to notice that we have a slant height over here. We need to find the height of this. So we're looking at this little piece of the problem right here. We know this is 4.1, and we know this length is 12.7, and we need to find the h, the height of this figure, which means we need to use Pythagorean theorem. So it's going to be 4.1 squared plus h squared equals 12.7 squared. And we can subtract 4.1 squared from both sides. I don't really need the parentheses on that. The h squared equals, and then we can pull up the calculator. Again, I prefer decimals, but it is what it is. 12.7 squared minus 4.1 squared is 144.48. And then we need to take the square root of both sides to get that. So h equals, well, the square root of 144.48 is 12.01. And I guess I'm going to go 12.02 if I round to the nearest hundredth. A little bit weird here. Maybe we could even go to 12. Because it does say to leave our answers in terms of pi. But when we do the volume now, what's going to happen is we've got the volume equals 1/3 times pi times our radius, 4.1, I'm going to put that in parentheses, squared, 1/3 times pi times radius squared times the 12.02. And then we are going to type that into the calculator, except for pi, because remember, the problem says if we're working with a cone, we want to leave our answers in terms of pi. So 1/3 times 4.1 squared times 12.02 is 67.35. 67.35 pi, and our units are meters cubed. If you rounded that a little bit, like if you really went to 12 instead of 12.02, then we're going to get, let's see what we get, 1/3 times 4.1 squared, and then if we just get rid of that, then we would get 67.24. So there, 67.24, you can't see it there, try again. 67.24 pi meters cubed. I wasn't specific enough in the directions, but one of those two answers. If we look at letter C, and I must have deleted a B in the middle here, but we have a pyramid on this one, and it's the same idea. We have the slant height here. We're not given the height of the pyramid. It is a pyramid because a cone has a circular base. Our formula is going to be 1/3 times the area of the base times the height. So when we go back and look at this, we have to start with our triangle here, and we don't know what the height is. But it's going to look like this. We know this length is the 13. That's where the arrow is pointing to. There's that. We don't have this length down here to the base. But then when we drop it across here, instead of it being a distance of 10, it's going to be half of that. So this is going to be 5. And then we can find the height of the pyramid by using the Pythagorean theorem again. So what we've got is we've got 5 squared plus h squared equals 13 squared. If we subtract 5 squared from both sides, we're going to type that into the calculator. We get 13 squared minus 5 squared, which is 144. And then I'm going to have to write small, but we're going to have to take the square root of that, and the square root of 144 is 12. So the height of our figure here is 12, and now we can find the volume of the pyramid, because it's going to be 1/3 times 10 times 10, area of the base, times the height. That's our 12 that we just found. So once again, we pull up decimals, we pull up our calculator, and we've got 1/3 times 10 times 10 times 12, and we get 400, and it's cubic inches.